Hello everyone, it's a pleasure meeting you all in my mathematics class. Today I am taking yet another problem in solving a partial differential equation. See, this is a given partial differential equation. I have already explained what is a partial differential equation. Given a solution, how you can get the partial differential equation. Now we are going to see what if the partial differential equation is given, how to find out the solution for it. The solution means expressing this, actually finding the value of z. But in this particular problem, you see that this is the partial differential equation in which p and q are nothing but dou is the basic. P is nothing but our, see, P is dou z by dou x and Q is equal to dou z by dou y. So these are dou z by dou y. Now given this, how to solve the equation? Now I rewrite this equation as y squared plus z squared minus x squared of P minus 2xy of Q is equal to minus 2zx, and this takes the form as PP plus QQ is equal to R. This is Lagrange's equation. This is the Lagrange's equation. Now the solution to a Lagrange's equation is given as, see, I have written here, it is given as f of uv is equal to 0. The solution to a Lagrange's equation of this type is given by f of uv is equal to 0, where u and v are functions of x, y, z, and it is equal to, they are equal to constants a and b. How to find the functions u and v is now the question. How we are going to solve? That is nothing but the solution. So this is a solution. This solution this is a solution for this particular problem of the type a Lagrange's equation. Okay, now see, there are two methods of solving this. That is, after writing the subsidiary equation, given this equation like this, that is the Lagrange's equation, we have to write the subsidiary equation. The subsidiary equation I have written here. This is called the subsidiary equation, which is given by dx by p is equal to dy by q is equal to dz by r, where this p, q, r are as given in the Lagrange's equation. After writing this, now our job is to find that u and v, and the solution will be f of uv is equal to 0. So this is what I am going to do. And identifying this, see, I identify this Lagrange's equation with a given problem. You find that this is our p, see, this is our p, this is our q, and this is our r. So this is what I find here. So I am able to identify, comparing the Lagrange's equation, what is capital P, what is capital Q and capital R, and therefore I can write this subsidiary equation as dx by y squared plus z squared minus x squared is equal to dy by minus 2xy is equal to dz by minus 2zx. Having got this subsidiary equation, now we have to find the u and v, which are nothing but functions of x, y, z, so that f of u is equal to 0 is the solution to the problem. So this is what I am going to do. Now for getting this u and v, two methods are used. One is grouping method and the other one is using the multiplier method, in the sense that I group them in order to find u, and I go for using the multiplier method, so that I will be able to get the the equations, that is the functions either u or v. How? See, for example, you see that I am going to couple these two, that is I am going to group these two. So I mind that this obeys the law of ratio and proportion. In the sense that if A by B, see if A by B is equal to C by D, it is like this. If A by B is equal to C by D, then this implies A plus B by B is equal to C plus D by D, or A plus B divided by A minus B is equal to C plus D divided by C minus D. All these are laws of ratio and proportions, and I will be using these ideas here to get the functions u and v. So mind that these are all the preliminary things or the basic things that a student got to know. Okay, I presume that those who are watching this video know about this rule, that is the ratio and proportion properties and rules. Okay, now so you see that this is what I am having. Now I take group these two. I take these two. Now dy divided by minus 2xy is equal to dz by minus 2xz. Now you see that conveniently minus 2x goes off, giving you dy by y is equal to dz by z. And see, this is nothing but what? So this is nothing but, so you can write this as, if you are going to integrate, if you are going to bring it to the other side, whatever you want you can do. What I will do is dy by y is equal to dz by z means, it is, if you integrate, this is log of y is equal to log of z plus log of a. I will repeat this. When you integrate this, this is log of y, and when you integrate this, it is log of z. So I bring it to the left hand side, that is why I write it as minus log of z. And you can either write a constant, log a is a constant, a is a constant, log a is a constant. Now you see that this log a is a constant. Now this is nothing but log a minus log b. Log a minus log b is log of a by b. That is why log of y by z is equal to log a. Log of, see here one step, it is nothing but what? Log of y by z is equal to log a. So this is, from this you can write log of y by z is equal to log a. Since both of you have got the log on both sides, you can write this as y by z is equal to a. Now you see that this u is nothing but what? So I am able to get a function which is equal to a constant. So you take this u as your y by z, which is nothing but a. So this is one of the equations I am able to get. So I told you that we want f of u is equal to 0, where u is a function of x, y, z and v is a function of x, y, z. But in this case, our u is a function of y and z. X is not present, but that is, it is as good as we can accept this. Okay, so u is equal to y by z, which is equal to a. So I am able to get one of the functions u here in this problem. Now let me go for finding the next one, that is v. How to find v? Now here I use the method of multipliers. What I do is, see, all these ratios can be equated to a common quantity with which obeys the laws of ratio and proportion. That you must understand. So what I do is, I multiply this by x, multiply this by y, multiply this by z. When you multiply the numerator, denominator must also be multiplied. So you see that, so each ratio is equal to, say I have written here, each ratio dx by this is equal to dy by this is equal to dz by this is equal to x into, see, x into dx plus y into dy plus z into dz divided by x into y squared plus z squared minus x squared plus plus y into minus 2xy plus z into minus 2xz. So I will repeat this. You multiply the numerator and denominator by x, multiply this by y, numerator and denominator, multiply the numerator and denominator by z, and all these ratios are equal to sum of all these, in the sense that multiply this by x, multiply this by x, multiply this by y, this also by y, this by z, this by z. Then all these ratios are equal to x into dx plus y into dy plus z into dz divided by, what I do is, I take this x. What happens is that, here you see that here this, when you multiply this, so this is x into y squared plus z squared minus x squared minus 2y squared minus 2z squared. When you simplify the denominator, you will get it as x dx plus y dy plus z dz divided by minus x. You can take this because it is y square minus 2y square is minus y square minus x square plus z square minus 2z square is minus z square. So you take this minus sign inside, outside you will get it as minus x into this. Minus x within brackets x square plus y square plus z square. So each ratio is equal to this. Understand that this obeys the laws of ratio and proportion. Okay. So this is equal to x. Now these are all called the multipliers. See, this L is the L, x, y, z are nothing but the what? The multipliers. So you can multiply provided you multiply the numerator and denominator with the same quantity. Okay. Now, so you see that this obeys the laws of the ratio and proportion. So I am justified in writing like this. So I do the simplification here. So I take this minus. As I told you, each ratio is equal to this. So conveniently I choose this ratio is equal to dy by minus 2xy. See, I have written here. This ratio is equal to dx by of this minus dy by 2xy dz by minus 2xz. This is equal to each ratio. I choose this and this. I choose this and this. This is, that is dy divided by minus 2xy is equal to x dx plus y dy plus z dz divided by minus x of the quantity I have written, x square plus y square plus z square. But this minus sign and minus sign will get cancelled, leaving you with what? Here you have got this, leaving you with x dx. See, it is like this, x dx plus y dy plus z dz divided by this is equal to, you will get it as dy by 2y. See, dy by 2y. So now what I do here is that, you see that I see it requires a certain manipulation. That is, you have to, now you have this, if I am to integrate, see, this is what I am having. See, I have written here, see, this is equal to this. And so you see that this part, you can see this one. This is very, very important. After simplification, I have got this. Now, if you integrate this, when you integrate this, you will get the next function, namely v. That is, this one I am going to integrate. But for integrating that, you must have a good knowledge or a certain manipulation of the terms required. So what I do here is that I write it as, see, this x dx plus y dy plus z dz can be written as d of x squared plus y squared plus z squared. So now if you take the differentials, you can see that this is 2x dx plus 2y dy plus 2z dz. 2 and 2 will get cancelled, leaving you with what? X dx plus y dy plus z dz. I don't make any change, but I write it in such a way that I will be able to integrate it easily. Nothing more than that. So if I take this and I write it as d of this, if you do take the differentials, you will get the numerator. And you see that half of, because you will get 2 here, therefore this compensating it, I divide it by 2. So it is d of x square plus y square plus z square divided by half into your denominator, you have got x square plus y square plus z square. On the right hand side, you have got dy by 2y. See, dy by 2y. So these two will get cancelled. See, these 2 and these 2 will get cancelled, giving you what? Giving you d of x square plus y square plus z square divided by x square plus y square plus z square. I write it here. See, plus z square is equal to dy by y. Now integrate both sides. You will get so this is integrating this, and here you must know that here a constant will come. See, integration of this plus integration, you integrate this plus a constant will come. See, I will write it as log b. So when you integrate this on the left hand side, right hand side is integrated. Whenever you integrate, you see that this is not a definite integral. So you see that therefore this constant should come. So I write it as log b, because you see that I identify this as, see, let me call this as our, see, q, or I will call it as some y, is that, see, some name you can give, see, d is it is of the form ds by s, where this s, it is of the form ds by s, where s is your x square plus y square plus z square. What is the integral of this? This is log s. So if you take this x square plus y square plus z square as s, this is of the form ds by s, and this is dy by s, as you know very well. Now, you know about this integral, but you have to identify this as what? Take this x square plus y square plus z square as s. So you get it as ds by s. The integral value of that is log of s, and this is log of y. Therefore, you get log of x square plus y square plus z square is equal to log y plus log b. That is, now see here I am writing, see, since I want the space, so I call this as equation number 5, and this is, so 5 becomes, so what does that 5 becomes? See, 5 becomes, this 5, it becomes log of, say I bring it to the left hand side, log of x square plus y square plus z square minus log y is equal to log b. You can even take it as b. I take it as log b because I can get both sides, I can cancel and get as without log. That's why I am taking it as log. So log of x square plus y square plus z square minus log y is equal to log b. Now you see this is nothing but log a minus log b. So this is nothing but what? So this place is nothing but log a minus log b. That is log of x square plus y square plus z square plus divided by y is equal to log b. So this is what, this I have skipped one step. So you see that this you get it as log of x square plus y square plus z square divided by y is equal to log b. Therefore, you can cancel log on both sides, in the sense that it is, since you have got log on both sides, you can write this as x square plus y square plus z square divided by y is equal to b. Now, this is nothing but what? You call this as your v. Therefore, v is equal to b. So, I have got one more function v, which is a function of x, y, z, and it is equal to a constant because of integration. Now, so therefore, the solution to this one. So, this is the problem. So, the solution to 1 is given by f of u v is equal to 0. That is, f of one of the functions is, see, I have got here. See, here you have got here. One of the functions, y by z, and another function is what? This one. See. So, this one and this one, that is y by z, comma, x square plus y square plus z square divided by y is equal. So, this is the solution to the given problem. So, this is all about the problem is over.